as you do the examples, I think you'll be okay. So this says some playing cards are not black. Some playing cards are not black. What you want to do is look in your chart down here to find anything that works. This says some something are not something else. So do you see anything that says some? Well, that's some A are B. I don't want that because this has a not in it. The one that has some A are not B is the same as saying not all A or B. So we need to use this format, but we need to stuff in these words of playing cards and not black. So not all A, not all playing cards are black. Not all playing cards are black. Okay. No bushes are silver. Look down here and see if you find anything that fits the no something are something. You see it? Right there. No A or B. So what was our A? Our A was the bushes. Our B was the silver. So this is no bushes are silver. Is the same as saying all A, which was bushes. So all bushes are not going to fit this in, are not B, which was silver. So all bushes are not silver. It will take a lot of practice on these. When you do your homework, I suggest that you do click similar exercise several times to get different examples that come up so that you can practice with the chart and go back and fit your format. Now we're ready to talk about negating a quantified statement. You know, to negate something, we just put a not in the statement or we took away a not. But when you're dealing with a quantified statement, you have to be a little bit more careful. So the negation of a statement about all objects is not all. All students in college are taking history. The negation of that is not all students in college are taking history. Because all students in college are taking history is a true statement. To negate that statement, we need to find at least one student in the college who's not taking history. That's why the negation is not all. Now, equivalently, not all can be expressed as some are not. So you can say not all students in college are taking history, or you could just say some students in college are not taking history. So the negation of all is either to change it to not all or change it to some are not. And once we look at some examples with the chart, this will be a little bit more clear to you, I think. So think about negation being the minimum that it would take to prove the statement false. The minimum to prove this statement false would be to find one student or to find some students that are not taking history. If you're going to negate a statement about some objects, the negation is not some, which is really weird phrasing. So not some can be expressed either by saying none or not any. So if the statement, the true statement is some students are taking math, the minimum it would take for me to prove that statement false is to say none of the students are taking math. Because some might just refer to one student. One student is taking math. So the negation of that one person taking math is that none of the students are taking math. Or you could say not any of the students are taking math. You would not say not some of the students are taking math. So here's our little chart. If you have the statement all A or B, the negation is some A are not B. So here's an example. All people take exams honestly. All people, that's our A, take exams honestly is our B. The negation of that is some A, which is some people, do not take exams honestly. Another statement, some A are B, its negation is no A are B. So some roads are open. The negation of that is no roads are open. And this little chart here can also help you figure out the negation. You want to look on the diagonal. The negation of all A or B is some A are not B. It also works this way. If you start out with this statement that fits the format some A are not B, its negation goes back up the diagonal to all A or B. And same thing with this diagonal. Some A or B, the negation is no A or B, and vice versa coming down. So let's look at some examples. I want to write the negations of the following quantified statements. I'm going to use this chart. This would be something that you would put on your index card to help you out. Also have this in front of you when you're doing your homework. So, all humans are mortal. This fits the all A are B. All A or B is right here. The negation is some A, and A is our humans. Some humans are not B. And what our B was mortal. So humans was the A, mortal was the B. Some students do not come to class prepared. So some do not come to class prepared. You see the word some right here. This says some A are B. I got a not in here, so I can't use that one. Come over here. Some A are not B. So some students are A, and not coming to class prepared. So the negation is all students, all A, all students come to class prepared. Notice in this format we had the not, so I'm taking the not out because there is no not up here, and that leaves me with all students come to class prepared. Some psychotherapists are in therapy. So psychotherapist is my A, therapy is my B. This is some A are B. Some A are B. My negation goes right up the diagonal to be no A are B. No A are B. And then go back and fill in your words. No, I'm not going to spell it all out. No psychotherapists are in therapy. The last one, no well-behaved dogs shred couches. So we have well-behaved dogs is A, shredding couches is our B, and it says no well-behaved dogs shred couches. Do you see the one? Do you see the only one that starts with the word no is right here, no A or B. The negation comes right down the diagonal, and it will be some well-behaved dogs, I'm just going to call them WB dogs, shred couches. Notice there was no R in this sentence, but when you've got a verb, it's going to take the place of the R's in this little chart. Multiple choice. We've already seen this statement a minute ago, but now I'm asking you to do the negation of it. So some bushes are not silver. The bushes are my A. The silver is my B. Look over here and see which is your some A are not B. Some A are not B. Go up the diagonal, and it would be all A are B, which is all bushes are silver. And that's A. Now you're going to have to do both on this one. This first asks you to come up with an equivalent statement. It says not all cars are red. Not all cars are red. So I look here, I don't see a not all, but remember these are equivalent right here. Here's my not all. Not all A are B. So that's one statement. Its equivalent is over here. So the equivalent to not all A or B is some A are not B. So some A, which is cars, are not red. Some cars are not red. Now we're asked to do the negation of this statement up here. Well, if you look down here, do we have anything in this chart that says not all? There's not. We know that not all cars are red is equivalent to some cars are not red. Do you have a some are not in this chart? Yeah, right here. Some are not. Go up your diagonal, and you're looking at all A, which for us was cars. All cars are red, which is right here. So what we had to do there was first do an equivalency so that we could use this little diagonal chart.